Let's use the direct comparison test to check the convergence or divergence of the following series. First one we have is sum from n equals 1 to infinity of 1 over n squared plus 1. Because we have here exponent 2, this will relate very closely to 1 over n squared. So we expect this to converge by the p-test. So for a comparison, you want to find something bigger, because if something bigger converges, then anything smaller will also converge. So we want to find something bigger than 1 over n squared plus 1. And the way to do that is to make the denominator smaller. So we'll make it smaller by removing the plus 1 here. So we'll just have 1 over n squared. And we know that 1 over n squared will be bigger than or equal to 1 over n squared plus 1. So this converges by the p-test. So by the comparison test, the direct comparison test, anything smaller than this will also converge. So therefore we say that this series converges. Next example, we have n equals 1 to infinity, 1 over 2n minus 1. This looks very closely to 1 over n, so we would expect this to diverge. So if we can show, using the direct comparison test, if we can show that something smaller diverges, then something bigger will also diverge. So we want to find something smaller than 1 over 2n minus 1. And the way you do that is by making the denominator bigger. So we'll make the denominator bigger by adding 1. So we'll just have 1 over 2n. So you can think of this as 1/2 sum from n equals 1 to infinity, 1 over n. So we'll just factor out the 1/2. And this diverges, because it's the harmonic series. So anything bigger will also diverge. So therefore, by the direct comparison test, this series diverges. Next example, we have the sum from n equals 0 to infinity, 1 over 4 to the n plus 1. This looks very closely to 1 over 4 to the n, which is a geometric series with ratio 1/4. So we do expect this to converge. So we better find something that is bigger than it. So the way you get something bigger is by making the denominator smaller. So we'll just remove the 1, and we know that it's bigger. So this converges by because of the geometric series, where the ratio is, the absolute value of the ratio is less than 1. Here obviously it's 1/4. So by the direct comparison test, anything smaller than it will also converge. So this series converges.